Good morning. It is day 2 of you being at home. So if you're in group A this week, you are currently working on this on Thursday. If you are in group B, you are working on this on Tuesday. Today we're going to be doing lesson 8. So I pulled it up in the from Google Classroom, the entire math, and we're going to get working on it. Remember to do these on paper and take a picture. All right, exercise 1. So today we're going to be working on equivalent ratios defined through a value of a ratio, and that'll become clear a little bit later. First of all, circle any ratios that are equivalent from this list below. Okay, so we can say 1 to 2. Let's do the relationship. The first one is half of the second one. So if we can look here, is 5 half of 10? Yes, it is. So we can do this one and this one are the same. Okay, what about this? Is 6 half of 16? It is not. So we're not going to circle that. Is 12 half of 32? It is not, so we're not going to circle that. So that was pretty easy. Okay. Now it says find the value of ratios. Leave your answer as a fraction, but rewrite the fraction using the largest possible unit. Okay. All right. So 1/2 would be, or 1 to 2 is just 1/2. So that was easy. 5 over 10, okay, is also equivalent to 1/2. So that would also be 1/2. And it says largest possible unit because 5/10 tenths are smaller than halves. So we're going to make that half. Okay. Now 6 over 16 is just going to be 6/16. But we can actually make that a little bit smaller by saying what's half of 6? Well, half of 6 is 3. And half of 16 is 8. And that's as small as we can get there because 8, we can't cut it in half again, and nothing goes into 3 and 8, okay? All right, well, now I'm looking at 12/32, or 12/32. So I go 12 over 32. Can that get smaller? It absolutely can. What is half of 12? Well, half of 12, and we're just cutting it in half so that we can get to a bigger unit, because 30 seconds are actually really, really tiny. We want to get it as big as possible. So this number would get smaller, the denominator. So 12 divided by 2 is 6. 32 divided by 2 is 16. Can that get even bigger than that? Yes, it can. So what's half of 6? That's 3. And what's half of 16? It's actually 8. And if you take a notice here, this and this is exactly the same. So if you wanted to, you could come back up to problem 1, and the 2 that we crossed out were the same because they're both 3/8. They're equivalent. All right, exercise 2. Here's a theorem. If A to B with B not equaling 0 and C to D with D not equaling 0 are equivalent, then they have the same values, A over B equals C over D. This is essentially stating that if 2 ratios are equivalent, then their values are the same when they have values. Can you provide any counterexamples to the theorem? So can you ever prove that A over B does not equal C over D? And the truth is that you can't, because A over B, if we were to put in 1 over 2, okay, and then we put in C over D, if they are equivalent, right, then we would have to say then this is also going to be 2 over 4. Are they equivalent? Yes, they are, because from here to here, it doubles. So from 1 to 2, it doubles. And from 2 to 4, it doubles. And it's going to keep doing it no matter how many. You go 3 over 6, it still doubles from the top to the bottom. You go 4 over 8, it's always going to be equivalent. Okay? All right, exercise 3. Tavon is training for a duathlon, which is just 2 things. It's a race that consists of running and cycling. The cycling leg, or the part of the race that's on the bike, is longer than the running leg of the race. So while Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every 14 that he puts in on his bike. Okay, so this is running. Remember to label over 14. Identify the ratio associated with this problem. Well, that was easy. It's 4 to 14. Now it says use the value of each ratio to solve the following. When Tavon completed all of his training for the duathlon, the ratio of total numbers he ran to the number of miles he cycled was 80 to 280. So 80 to 280. Now, it says that this was number he cycled to his total number. Okay, oop, shouldn't be that. I apologize. I don't know how to erase on here. So this should actually be total. Just right over it. Total, okay? It should say total. All right. Is this consistent with Tavon's training schedule? Explain why or why not. So this was 4 to 14, okay, was how much he ran to biked. If we add those up, how much did he do altogether? That was 18, okay? And so cycling would have been 14 out of 18, right? Would have been cycling over run or total. Well, right here we're looking at total numbers he cycled and total, which was 280. So it's asking, is this equivalent to this? Well, if we double it all the way up, okay, we can just see that this was just slightly smaller than this, okay? Is 80 slightly smaller than 280? Absolutely not. It's actually a lot smaller. So I don't actually have to do math here. I can just say, no, it's a lot smaller. So the answer was no. And then I would explain that I estimated because the numbers, the ratios do not seem the same. Okay? So that's easy enough. C, in one training session, Tavon ran 4 miles and cycled 7 miles. Did this training represent the ratio of equivalent to the distance he ran to the distance he cycled? Explain why or why not. Well, up here, if he did 4 to 14. Down here, he did 4 to 7. Is that equivalent? It's actually not equivalent because you can tell right here, this ratio of running to cycling and this ratio of running to cycling he ran 4 and ran 4, so the running stayed the same, but the cycling changed quite a bit. So I would say no, and you could see that they are not equivalent. And I know the handwriting is bad, it's because I'm writing with the mouse. So not equal, okay? All right, so that is lesson 8. You are now going to go work on this problem set, which I believe is just 4 problems. It's not very difficult. If you have any trouble, that's okay. We can take a look at it in class next time you're here. But that is lesson 8, so get out of here. Goodbye.